Hey everyone, today we're going to continue with section 8.2. If you remember, we were finding the area that's trapped in between two curves. And yesterday we came up with some situations that can be a little bit tricky to deal with, so we're going to learn a way to kind of get around some of those issues. So just to step back a bit, we're going to review a problem that we did yesterday. And we're not going to go through and solve it, but we're going to set it up and take a look at what made it a little bit difficult. So we were asked to find the area of the region in the first quadrant that is bounded above by y equals square root of x, below by the x-axis, and the line y equals x minus 2. So first I'm going to graph this just to give us a picture of what we're looking at. Okay, so first I have square root of x. Give me a couple points, and I'm going to go ahead and do this one in this color. So here's y equals square root of x. Okay, I know one of my lower boundaries is going to be the x-axis. So here is that. And then I have the line y equals x minus 2. So I know it's going to be this line here. And again, we were asked to find the area in the first quadrant. So we're just focusing on the first quadrant. Now, the problem that came in here, we know that when we're finding the area between curves, we're doing the top minus the bottom and integrating. However, in this case, if I start going here, I could see there's my top and my bottom. But when I get to this point, the bottom changes from being the blue to being the orange line here. Right? So we ended up having to split our integral. So we knew the area was the integral from 0 to 2. Again, we did top minus bottom. So that was square root of x. And really, even though we wouldn't normally write it, we know our bottom was 0. And then we had to add our second integral, which went from 2 to 4. In this case, our top was still square root of x, but now our bottom switched to being the line, let's see, x minus 2. Okay, and so again, we're not going to worry about evaluating that for right now. But the issue here, the big point, is that this was challenging because the bottom function changed. At x equals 2. So we needed to split it up in those two integrals. So what we're going to learn today is a way of solving area problems that's going to make some of these easier. We won't always be able to get around it, but sometimes we will. And what it's going to involve is integrating with respect to y. So here's what it's going to look like. Instead of doing top minus bottom, when we're doing with respect to y, we're going to integrate. I'm just going to call these limits from c to d. And what we're going to do now is right minus left. So it might look like this. Integral from c to d of f of y minus g of y dy. So a couple things that are important here. Our limits of integration now, since we're in terms of y, are going to be y values and not x values. Sorry, squeeze that in there. It's really small, but that says y values. So our limits of integration have to be y values. And then you'll notice here in the integrand, our functions have to be in terms of y. So if I look at the same example we just did, let's see here. Try to use the same colors. Now I've got this. And I have this line here. Now, if I call my orange line f of y, and my maroon line here g of y, now if I integrate from right to left, I can see my right function is always the orange, and my left function is always the maroon there. So I don't have the need to split this up into two integrals. So actually, we're going to take that problem, do it now with respect to y. So again, we're working with the same function, but we're going to do it with respect to y. And I'll kind of step through this here as we go. So I'm going to graph this for the third time here. Okay, so first one we had was y equals square root of x. We knew one of our boundaries was the x-axis. And then we had the line y equals x minus 2. Okay, so now we're going to integrate with respect to y. Again, that means we'll only need one integral because our right and left boundaries don't ever change. So the first thing we're going to do, I'm going to make some notes about the steps here. First thing we need to do is solve both functions for x. Right? When we're integrating with respect to y, we need them in terms of y. So let's go ahead and do that. We've got y equals the square root of x. So I know to get x by itself, I square both sides, and so I get x equals y squared. So I'm just going to write that next to my function here so I keep track. This is x equals y squared. My other one is y equals x minus 2. So to get x by itself, I'm going to add 2 to both sides. So I get x equals y plus 2. And that's here. Okay, so now I've got that set. Sorry, that orange isn't showing so well. There it goes. Okay, the next thing I need to do is find the limits of integration. And remember, when we're integrating with respect to y, those have to be y values. So I'm going to take my two equations now that I have in terms of y, I'm going to set them equal to each other, just like we would have if we were in terms of x. So I have y squared equals y plus 2, or y squared minus y minus 2 is equal to 0. I can solve that by factoring. I'm going to get y minus 2 times y plus 1 equals 0. So y equals negative 1 and 2. So there are my limits of integration. And now, finally, we're just going to integrate. And remember, we're going to do the integral of right minus left with respect to y. So now we can put it all together. So sorry, I'm kind of jamming this in here. So now I'm going to have the integral, again, my y values. Now, I have to be a little careful here. My y values were negative 1 to 2, but we know we only want the area in the first quadrant. So actually, my lower bound is going to be 0. My upper bound is 2. Now, my right function is going to be the line y plus 2. My left is going to be y squared. And then I'm going to integrate with respect to y. So again, I'm just going to make a note here. This was right. Whoops, that should have been an orange. Not doing really well with my colors. So right, this guy was my left. So I'm doing right minus left. And for the sake of our purposes here, we'll just put this in the calculator. So let's see, we're going to do Math 9, integral from 0 to 2. Again, this is y. In my calculator, I'm just going to enter it as x. So x plus 2 minus x squared with respect to x. And I get, that's approximately 3.333. So again, the whole purpose of this is just to avoid having to use two integrals if we can. All right, let's go ahead and look at a couple more examples. Okay, here now, they're actually asking us to make a choice. So we can do it both ways. It's just important to understand when each way might be better. So we're going to find the area of the region enclosed by the graph of y equals x cubed and x equals y squared minus 2. So first, I want to be able to graph these, so I'm going to get both of my equations solved for y, just so it's easier to graph. So I already have y equals x cubed. And then this guy is going to be y squared equals x plus 2. So y equals positive or minus square root of x plus 2. All right, so let's look at what it would look like to do this with respect to x. And remember, when we're doing with respect to x, it's top minus bottom. So my graph is going to look like this. I know y equals x cubed is going to look like this. I'll leave that y equals x cubed. I'll do this in another color so we can see. Positive or minus square root of x plus 2. Well, that's going to be our square root of x function, but shifted to the left. So it's going to look like this. So actually, this top piece is square root of x plus 2. Bottom is going to be opposite square root of x plus 2. So now what I notice is if I do top minus bottom, here I've got this top and bottom, but then now my bottom is going to switch here. So if I'm going with respect to x, I actually need, whoops, I'm going to keep going here. I'm going to need two integrals. So first I've got the integral, and we'll look at our limits in a second here. Let's see, my top was square root of x plus 2 minus, my bottom is actually opposite square root of x plus 2 dx. And then I'm going to add the integral, and we'll get our limits again. My top is square root of x plus 2, and my bottom there is x cubed dx. Now, we're going to go ahead and use our calculator to find these limits. So let's see. I'm going to put these graphs in. I've got square root of x plus 2. I've got the opposite square root of x plus 2. And I've got x cubed. I need to change my window. I should put this in a place where you guys can see that. Okay, so here comes our graph. So now I need to find my intersection points. And actually, I'm going to narrow my window a bit here so it's easier to see. Okay, so now we're going to find our intersection points. I'm going to do calc intersect. Now, I need to pay attention to what function I'm on. So I actually want to find my left limit of integration here. So now I want to jump down. Let's see, where am I? Here I am. I'm on x cubed, which is fine, so I'm going to hit enter. Now, it jumped me up to this top curve here, which actually isn't what I want. So I'm going to use my bottom arrow. Now I'm on the curve that I want. I'm going to hit enter, hit it again, and I know that x coordinate of that intersection point is going to be -1. So I'm going now from -2 to -1. And now here I'm going to have plus -1, and we'll go ahead and find our next intersection point. I'm going to hop up to this curve here. Oops, I need to calc intersect. Okay, I'm on my top curve, square root of x plus 2. I'm going to hit enter. Now it's going to jump me all the way down. I need to go back up to my x cubed. There I am. I'm going to hit enter again. And that intersection will estimate about 1.215. So we're just going to go ahead and put this in the whole integral in our calculator now to calculate it. So I've got math 9, negative 2 to 1, square root of x plus 2, minus a negative square root of x plus 2, dx, plus the integral from negative 1 to 1.215 of square root of x plus 2 minus x cubed dx. And we get a value of, let's see, I don't think that's right. Sorry, I just realized you couldn't see the calculator, and I realized I had the wrong upper limit here, so I'm going to run that again. And we get 4.215 for the value of that integral, or the area between those curves. Now again, that's a little bit messy because we needed the two integrals. So let's take a look at what this would look like with respect to y. Again, we have our same functions here. This time I'm going to be a little more careful. Let's use this purple for x cubed. Now, if I'm going with respect to y, I know that I want this function in terms of y, so I actually have x equals the cube root of y. My other function, y squared minus 2, again, is going to look like this. This is x equals y squared minus 2. Now you can see that to find the area, my right and left boundaries stay the same over that whole interval. So now I need to go back if I'm going to integrate this. I know my right function is cube root of y minus y squared minus 2. And that's with respect to y. I need to go back and get the y values of those intersection points. So I'm going to go back to my graph. I'm going to do calc. There's such a glare on this. There we go. Calc, intersect. I'm going to go back over here. Let's get to this curve here. So here we go. I'm going to hit enter. I'm on x cubed, which is good. Now the y value this time is negative 1. So that's going to be my lower limit of integration. My upper limit, I'm going to do intersect to get the y value of this point here. So let's go over, enter, come up here. And now my y value looks like 1.793. So now I've got one simple integral. I'm going to use my calculator again. Let's quit here. Let me put this where you can see it this time. All right, math 9. I have negative 1 to 1.793 of, let's see, x to the 1/3 minus x squared minus 2 dx. Hopefully it's going to come out the same. If it doesn't, then I know I did something wrong. And there we go. We get 4.215. So either way, it comes out the same. There's just a little more work involved with one way versus the other. So I'm going to leave it at that for today. Number 3 we can use as a warm-up tomorrow to kind of flesh out any questions that you might have before you start on the practice.